Hello everybody, Namaskar. Today we will study about dehydrated vegetables. Okay. In this lecture we will see what are the various vegetables which are dehydrated and the dehydrated vegetables available in the market, technologies used for drying of these vegetables, and in the vegetable drying, particularly leafy vegetables etc., major problem has been found to be retention of the green color of the vegetable in the dried product as well as their rehydration characteristics. So, we will also discuss some methods for color retention and improvement in rehydration characteristics of the dehydrated vegetables, and finally, we will discuss about the technologies for the onion dehydration, drying of okra chips, green peas and cauliflower, osmo air drying of tomato and osmo freeze drying of carrot flakes, and spinach and amaranth leaves drying. Okay. So, let us see what are the dehydrated vegetables. You can see here in the picture various vegetables in the different forms. They are dried because in the season they create a glut, and out of the season they become scanty, and because of their perishable nature during the production season they become in plenty and lot of spoilage occurs. So, in order to preserve their shelf life as well as to use these vegetables in the seasons of when they are not produced or in the areas where they are not produced, these vegetables are dehydrated using appropriate technologies, either in the forms of cubes or in the slices or in the form of chips or finger chips etc. So, in the different forms they are dried, but as I told you that during the dehydration of these vegetables, particularly in the leafy vegetables etc., the care should be taken, the drying technology should be used in such way that the color of the dehydrated product is better, and also that these dehydrated vegetables before cooking, before consumption, they are required to be rehydrated. So, they should have a better rehydration characteristics. Okay. Various techniques which are used for dehydrating vegetables are those solar drying, hot air drying, vacuum drying, freeze drying, fluidized bed drying, microwave drying, foam bed drying, spray drying etc., depending upon the type of the end product that is required, and the various details of all these processes, drying techniques, equipments required and process parameters etc., we have already discussed earlier, and those things holds true here as well. The pre-treatments, very important operation before the dehydration of vegetables. So, these are the obvious pre-treatment like sorting, washing, peeling and then cutting into the appropriate forms, and finally, the blanching. These are the some of the pre-treatment which are given, and we have again in the earlier classes we have discussed the details of these processes. Okay. So, in this class today particularly I will little bit elaborate what are the various pre-treatment which should be applied in the vegetable depending upon its nature to retain its color in the dried products. So, the one is the thermal branching, which is widely used method to inactivate enzymes and microorganisms. Okay. So, when the thermal branching is applied, it softens the tissues for facilitating drying process and eliminates intracellular air to prevent oxidation. Also, it decreases the reducing sugar content in a product by blanching can reduce browning and improve product color. Superheated steam impingement blanching inactivate oxidases rapidly and therefore avoids browning. So, basically the browning reactions are eliminated by blanching, or even sulfur treatment is done sometime, which can also prevent the initial condensation reaction by forming non-reactive hydroxysulfide sugar derivatives. It is usually performed using sulfur dioxide gas or water soluble sulfide salts like potassium metabisulfite, sodium metabisulfite, sodium hydrogen sulfide, etc. Okay. Also, that sometimes acid treatment is given to certain vegetable, again for not all vegetable, but for some suitable vegetables, acid treatment like they can be dipped in citric acid, malic acid or phosphoric acid or ascorbic acid solutions, so that their pH is lower down. All right. And as you know that the pH of the optimum activity of polyphenol oxidase, which is responsible for the browning, is in the range of 6 to 7. So, by acid treatment the pH of the commodity is lower down, so that the enzymatic reaction is that. Okay. And PPO activity is completely stopped when the pH is lower down to 3 or below, but the lowering of the pH may have some important influence or effect on the sensory characteristics of the product. So, that should be taken care of. Then osmotic solution, that is dipping it in osmotic solution can inhibit enzymatic browning and stabilize the color of the products. And these pre-treatment of product before drying with a sodium chloride solution at moderate concentration significantly reduces the overall color change. Osmotic treatment lowers the water content in the vegetables, which subsequently reduces thermal drying time that induces lower color changes. So, these treatments also they prevent browning as well as they facilitate the drying process, expand the drying process. Then rehydration of the dried vegetable, as I told you that the dehydrated products are rehydrated before they are cooking, etc. Okay. So, either by soaking method or by other method. In the earlier lecture on the fruit we have discussed about rehydration characteristics of the dehydrated products. So, same thing also holds true here, but rehydration basically that is the process of moistening the product, a dry material, and in order to bring it to the original shape. Okay. So, if the material is porous, if there are capillaries and cavities in the dehydrated product near the surface, this improves rehydration characteristics. Also, the presence of amorphous region inside the product improves rehydration characteristics. The presence of tapped air bubbles, crystalline structure or presence of annoyance in water creates obstacle in the rehydration. So, this pre-treatment as well as the drying process should be selected in such a way, their process parameters should be selected in such a way, so that the dehydrated material is porous, it has sufficient capillaries, etc. So, which it will facilitate the rehydration of the product. Normally, that the rehydration characteristic of material is expressed in two ways, either it is rehydration ratio or even rehydration coefficient. Rehydration ratio is the ratio of mass of the rehydrated product Wr to the mass of the dried product Wd. Rehydration coefficient, if the weight of the rehydrated product is Wr, weight of the dried product is Wd, and its moisture content of the dried product is Wu. If the initial raw material vegetable before drying had a moisture content of A%, then the rehydration coefficient can be calculated using this equation. Rc is equal to Wr multiplied by 100 minus A divided by Wd minus Wu multiplied by 100. So, using this, and obviously that higher the rehydration coefficient or rehydration ratio, will higher the value for this, the better is the rehydration characteristics, better will be absorption of moisture. Now, the traditional treatments to improve rehydration in dried vegetables, including soaking in the sugar solutions or in acid solutions, which also we discussed in the for the as a blanching treatment or to improve the color. So, these also they are reported to improve the rehydration characteristics in various vegetables. Even alkaline ethyl oleate solution, that is 2% ethyl oleate plus 5% K2CO3. This improves the skin permeability and removes the waxy layer on the surface So, obviously, it creates that is faster drying and which creates better pores, etc. Then ethanol treatment also increases the permeability of the thinned cell walls and it modifies the microstructure. So, it improves the rehydration characteristics of the dried product. Okay, sorry. Then there are novel pretreatment techniques to improve rehydration in dried vegetables are pulse electric field, ultrasonication, high humidity, air blanching, microwave blanching, etc. And these all creates better pores inside the porous dehydration matters, and the principles of all these methods we have discussed earlier in the drying of the fruits, dried fruit ready to eat products. So, the same principle applied here also. Okay. And now we will take up the products. First, the onion dehydration. You know that is the onion is the most commonly used vegetables in food preparations. It contains moderate amounts of protein, fat, fibers and good amounts of calcium, phosphorus, potassium and even vitamin C and B6. So, the pungent taste of onion is mainly due to the presence of volatile oil, that is allyl propyl disulfidyl isothiocyanates, etc. Okay. That is, onions are generally dried from an initial moisture content of about 88 to 90% to 6 to 7% wet basis or less for efficient storage and processing. But in the drying of the onion, it has to be taken care that its bioactives, they are very good source of bioactives and the pungency, if that should be prevented. So, the Indian onion varieties which are suitable for dehydration are the white flesh onions like Bombay White, Udaipur 102, then Pusa White Flat, Pusa White Round, or red onion varieties like Ronali, Udaipur, Pusa Red, and Agrifold Light Red, Agrifold Dark Red, etc. That the details are given in the slide, you can read. Then this is the process technology for the preparation of onion or drying of the onion. Okay. So, requirements for the onion processing include that is their high total soluble solids, high degree of pungency that I told you. Onion has high insoluble solids. Okay. So, they should be retained in the dried products, lowering low reducing to non reducing sugars ratio to avoid caramelization and high yield and good storage quality. So, that should be these should be the characteristics on the dehydrated product, and accordingly the process technology should be used. And in one of the standard process reported in the literature is that as harvested onions, they are subjected to obvious pretreatments of sorting, grading, peeling, etc. Okay. And then generally flame peeling is done for the onions, and the bulbs which are used, they are medium to large size bulbs for drying. Then it is sliced, then generally 5 mm thickness, 88% wet basis moisture content is there. However, the thickness slices as depending upon the requirement, it may vary. Smaller the thickness, better will be the drying characteristic, drying dehydration. Then drying is normally done in the cabinet drying at around 55 to 60 degrees Celsius for 10 to 15 hours, and the moisture content in the dried product may be 6 to 7%. Okay. Then bin drying also, that is warm air circulation to reduce the moisture content to the less than approximately about 4%. So, that to have better storage stability. Then you get the dried onion, and these are further packaged in the polythene bag, but the packaging should be air moisture vapor tight and air impermeable. Okay. Then here a case study we are presenting a thin layer drying where the effect of slice thickness and the color change of the dried onion is shown in this first figure. Okay. Effect of temperature on pyruvate content, that is here the slice thickness is 2 mm, it is shown here. Okay. That is if the temperature is increasing, the pyruvate content is decreasing. Then in third figure you see here effect of slice thickness on the pyruvate content and the temperature is constant, that is the thickness is increased 2 mm, 5 mm or 10 mm, and this but temperature is 60 degree. So, it is seen that overall from this the inference is drawn that the slice thickness between 2 and 6 mm do not cause color change, whereas thickness above 6 mm strongly influence color of the dried product. So, to minimize color change in the thickness of the onion slices, it should be selected, that is the slices thickness should be properly selected, okay, and it should be, as I told you, as small as possible, because in that case the drying rate will be. The ability of the dried onion slices to produce pungent compounds decreased with increasing the drying temperature. The drying temperature had a more pronounced influence on the pyruvate loss than the slice thickness, and drying temperature above 60 degree should be avoided to achieve better flavor in the product. Okay. This is the process flow chart for the onion powder production. Okay. That is, the onion is taken, and after obvious pre-treatments, that is stem cutting and peeling, then finally it is sliced, okay, of appropriate thickness, and these slices are blanched at around 80 degrees Celsius for 5 minutes. Okay. Then these blanched slices are put into 1 to 3% brine solution for 30 minutes for osmosis. So, with the help of osmosis, some of the water goes out, and then these osmotically dehydrated onion slices are then subjected to tray drying. Okay. That is at 50 to 70 degrees Celsius for 8 to 10 hours. By this, onion flakes are obtained of suitable moisture content, less than about 5 to 6%, and these flakes are then pulverized, that is ground into fine particle in a suitable pulverizer, and then you get onion powder, and these are packed. So, here the onion can be packed in the form of flakes also, and it can be powdered at the time of use, or even it can be powdered and then packaged and then sold in the market. But for packaging, again, like any other, all these products are highly hygroscopic, so the packaging material should be selected accordingly. Okay. And these dehydrated onion flakes and powders can be used in soups, sauces, salads, sprinkling, seasonings, pizza, etc. Vacuum packed onion has increased shelf life and can be used at a later stage, better shelf life. For vacuum packaging of the flakes, that is obviously, that is onion flakes are placed within the vacuum packaging machines. The airs are removed. Okay. After that it reduces the atmospheric oxygen, and this limits the growth of microbes and even evaporation of the volatile components. Okay. Then it is heat sealed inside the chamber, lid is then opened and the product is removed. Okay. So, the flexible packages, that is the forms, reduce the volumes. So, that is the vacuum packaging is recommended, it is better from the. Here it is the process layout for a onion processing unit, which is having a solar dehydration capacity. You can see the figure, that is that here one are these are storerooms, and 2 is the shelf, etc., where some materials, etc., can be kept. And then in the series, that is onion grader, that number 5 is conveyor, onion peelers, and then a compressor, etc. put. Then number 8 is vacuum packaging machines, and this is FFS, farm fill and seal machines. And then liquid filling machine, colloidal mill, and hammer mill or ball mill, vegetable slicer and blancher, etc. And then here is a vegetable solar dehydrator. So, this is the one way of it has been suggested, but anyway, placing of the equipment can be decided suitably for the ease of the operation. Okay. Then we will come to the dehydration of okra. Okra chips are a dehydrated version of okra. It can be consumed as a low calorie snack. Salt, spices and vegetables oils are added to boost its flavors and lengthen the shelf life. Okra's suitability for drying is fair to good. In fact, okra chips are a good source of potassium, magnesium, vitamin A, calcium and folate. For the processing of the okra or dehydration of the okra, there is a sorting, grading and washing according to the size, maturity and soundness. Okay, then these are cut into the 2.25 to 0.3 centimeter slices. These slices are blanched in boiling water, okay, and treated with sulfite solutions. Okay, and these are all to retard enzymatic browning, and then these blanched chips are dried in a cabinet dryer at around 55 to 60 degree for 6 to 8 hours, cooling at room temperature, and then packaging in appropriate pouches or storage. Okay. And then obviously the packaging material should be of desired requirement. So, post dehydration treatments in okra processing are that the sweeting, that is the sweeting involves holding the dehydrated product, that is dehydrated okra chips, in bins or boxes, so that the moisture content is completely equilibrated. Equalize the moisture content throughout the dehydrated materials. Then screening removes the dehydrated pieces of unwanted size, usually called fines. Then the inspection, obviously the dried product is inspected to remove any foreign materials, discolored pieces or other imperfections, and finally instantization treatments. These are used to this instantization treatment is used to improve the rehydration characteristics of the low moisture product. Particularly sometimes it is reported that radiation treatment or even PEF treatment of the dried products, etc., that can improve the rehydration characteristics. Then finally packaging. Okra can be stored in the glass jars, polypropylene pouches, tin jars or air lids at around 20 to 25 degrees Celsius for 6 to 8 months. These are the machinery which are used in the okra processing, like roller brush dryers, universal slicer, blanching tanks, tray dryers, impulse heat sealers or with the electric power, or vacuum packaging machines. Details of this are available. These are easily available in the market, and we have also earlier in the earlier classes we have discussed. Then another very important product is the freeze dried or frozen dehydrated peas. So, these peas are convenient and can be stored, that is frozen dried peas are very convenient. It can be stored in the form of fresh, okay, for longer time. So, obviously the harvested peas, that is grind, and then the waste is removed, then they are peeled, and you have the green peas beans, that is the flotation washer, etc., is used for cleaning the peas. And then sorting, the peas sorter consists of around 3 to 5 rotating closed leaf shaped perforated drums with a diameter of about 2 meter. Okay. Then it is blanched up to about 75 to 80 degrees Celsius by in the soaking for 2 to 4 minutes. And after that, these are the frozen, that is it may be frozen in a suitable equipment. The freezing already we have discussed in earlier classes, and after freezing it is the freeze dried at around -45 to -50 degrees Celsius, okay, and finally stored at -18 to -23 degrees Celsius, that is in the frozen freeze dried material. Okay. So, all this we have already discussed. Even if it is properly packaged, even it can be stored, that is the freeze dried products even can also be stored if it is suitably packaged at room temperature as well. So, in the you will be tested to know that only about 5% of the pea sold worldwide are fresh. So, basically the frozen pea can be stored at -18 to -23 degrees Celsius, but the freeze dried, once the moisture is removed, if provided if it is properly packed, it can be stored even under the ambient conditions. This is the machinery like a bubble cleaning machine, pea sealer, screw blancher, freezing machinery, then freeze dryer and packaging. These we have already. Here is the comparison of drying methods of pea, different drying method, that is in this there is a moisture content versus time, and in the second graph is the drying rate versus the moisture content, and different microwave vacuum drying, hot air convective air drying, and multi-stage drying like HP, FB, AFD plus MBD, or HG, FB, FB plus MBD, different drying. And in all these process combination and permutations, whether it moisture content or it is that is the drying rate or moisture content, that is the microwave that is the microwave vacuum drying is found better among all the processes. Okay. Rehydration capacity of dried peas, earlier we discussed that is either rehydration capacity or rehydration ratio, it is a WR by WD. So, the rehydration curve, as you can see here, it shows that an initial high rate of water absorption followed by a slower absorption rate in the final stage of dehydration is there. Initially there is a high absorption, and once capillaries are filled, then it goes for the diffusion, etc. And the rehydration capacities of the pre-treated samples were higher than those of the control samples at all drying temperature. The drying temperature were very different, drying temperatures were used, but AEFO, that is immersion in 2% ethylate, or citric acid dipping, blanching, or control treatment. So, the pre-treatment improved in all the cases, that is right. Similarly, convective drying of the cauliflowers, where drying was performed at different temperature 45, 55, 65 and 75 degrees Celsius. Air velocity used was 2 meter per second, and it, as you can see here in these figures, that is shown that the samples which were dipped in hot water blanching before drying process had a shorter drying time compared to the citric acid dip or control sample. Hot water contributed to increase the permeability of cell membranes of cauliflower slices, leading to an increase in the water diffusivity, and therefore, there was a better drying process. This is that was earlier in the earlier slide we discussed about the drying time fact, and now here we are comparing the rehydration ratio. Okay. So, the pre-treated samples, obviously they had higher rehydration ratio compared to the control sample, as you can see here in these figures. Blanched samples also had higher rehydration ratio compared to the sample pre-treated with citric acid solution and control sample. So, the rehydration ratio increased within the initial period. You can see initially it was rehydration ratio was higher, but towards the latter stages of the rehydration it was its rate slowed down. Okay. Now, we will discuss about osmo air drying of tomato. Okay. This again the selection of fully red tomato, washing, then blanching in boiling water, that is for 2 minutes. Then osmotic solution dipped by 4 to 5% sodium chloride at 50 to 55 degrees Celsius. It is dipped for about 45 to 50 minutes. Okay. Then cut into thin slices, dipping into 2% gelatinized starch solution for 10 minutes. Then cabinet drying, 3 stages. In the first stage drying, that about 55 degrees Celsius for 2 to 3 hours, and then temperature is reduced to around 45 to 50 degrees Celsius, and the drying is continued for another 8 to 10 hours. Then finally, the dried product is cooled to room temperature, ground pulverized into fine powder, and it is packaged in the powder form. It can be packaged in the powder form, or even it can be packaged in the slice form as well. Okay. And its quality attributes ascorbic acid, lycopene, rehydration ratio is reported to be better 1.5 to 2, and the recovery of the dried tomato powder was around 2.5 to 3.25%. That is, it is normally it is the solids content is around 4.5 to 5% in the tomato. So, there were less losses of lycopene under osmotic diffusion due to fewer cis isomers present there. Osmo freeze dehydration of the carrot flakes, okay, freeze dried carrot flake, carrot shreds after rehydration in boiling water for 1 to 2 minutes can be used in soup or curry preparations. Okay. And so, the carrots are washed, and then it is blanched, or it is grated into the form of thin flakes, and these flakes are blanched in 20% sugar syrup at 100 degrees Celsius for 2 to 3 minutes. Then immediate cooling in chilled water for 20 to 30 minutes. Surface moisture is dried at room temperature, and then finally it is freeze dried at 0.042 to 0.062 mbar and minus 92 to minus 98 degrees Celsius. Cooling and packaging is done in polypropylene pouches, and it is can be stored at 20-25 degrees Celsius for about 6 to 7 months. Okay. Spinach powder, here the same, that is spinach, fresh spinach leaf is taken, it is washed with water to remove dirt, it is then you get the clean spinach leaf, it is given a sodium hypochlorite treatment, about 40 ppm solution for 30 minutes, then cut into smaller bits about 3 centimeter length, and then it is dried at around 55 to plus minus 2 degrees Celsius using tray dryer for 8 hours. And in the trays, at least appropriate loading capacity, normally 2 kg per tray as we recommended depending upon the tray sizes. Okay. Then it is grinding and passing it through BS72 mesh, and spinach powder is obtained, maybe about 1.28 kg powder from the 20 kg of the fresh leaves, and it is packaged in metallized polyester or polythene pouches. And here in the figure I have given that this is taken from the literature, and they have reported the functional properties or nutritional characteristics of this spinach powder, and it is good. In fact, water solubility index of it is found about 4.23, even water absorption index is about 3.34, rehydration ratio is around 3.3. So it has a good characteristics. All right, it has around 329 kilocalorie per 100 gram, the calorific value. Okay. Now the drying of amaranth leaves, that is dried amaranth leaves, are fried in refined oil along with spices, followed by addition of water for rehydration during curry preparations. The amaranth leaves are sorted, graded and cleaned. After that it is washed. So washed amaranth leaves are blanched with 0.1% magnesium oxide, 0.1% sodium bicarbonate and 0.5% KMS solution at 100 degrees Celsius for about 15 to 20 seconds. And this is followed by osmotic diffusion treatment of 1% sodium chloride solution at 50 to 60 degrees Celsius for 15 to 20 minutes. And then osmotically dried samples are then sent to the dryer, the cabinet dryer, and the drying is performed at around 50 to 55 degrees Celsius for 4 to 5 hours. Finally, it is cooled and packaged, and it can be stored for 8 to 10 months at 20 to 25 degrees Celsius. So quality attributes of the dried amaranth is reported to be good. It has overall acceptability after 50 days of storage, it was found good, and the moisture content maybe during storage there is a little bit about 15 to 18% variation in the moisture content has been reported. This is a work from the ICR New Delhi. Okay. Then rehydration behavior and color attribute are microwave dried amaranth leaves. You can see in this figure that is the microwave power was used 700 watt and drying time was around 780 seconds. So rehydration of microwave dried leaves was successfully done at 35 degrees Celsius. The rehydrated leaves were darker than the fresh leaves color, and increasing the temperature to 50 degree improved the rehydration capacity and the color of the leaves. As you can see here also the figure, that is at 50 degrees Celsius the color was, or above the 50, the color of the rehydrated leaves was better. So finally I will summarize that yes, the vegetables appropriate technologies for the vegetables rehydration should be used, and not only for the drying, appropriate drying, normally novel drying, so that the bioactives and color etc. is improved, and also the rehydration, because these dehydrated vegetables they are rehydrated, so they should have a good rehydration characteristics. After their rehydration they should look like its fresh counterpart, and the packaging of these rehydrated product is very important aspect. We have already discussed earlier the different aspects of the packaging. So appropriate packaging material, because after the dehydration they have the porosity etc. porosity there, and they will be absorb the moisture if they are kept loose, and that way defeat the whole process. So novel methods of drying as well as novel methods of pre-treatment before drying or even sometime after the drying the dehydrated products may be subjected to some instantization treatment, so that it becomes a quick cooking and it gets a good moisture rehydration ability. So, these are the references that are used in this lecture. Okay. And finally, thank you very much for your patience hearing.